Hello class, welcome to lab 3, and in this laboratory we're going to take a look at some basic Python stuff and some advanced Python stuff as well, just the tools that you need to know in order to complete the programming project, which will be posted to the Canvas lab section. It should be in a folder called programming project, so just so that you're aware of that. But to start things off, we'll take a look at pretty basic pretty basic introduction on some of the stuff that you can do with Python. Here I'm using a program called Spyder, which is spelled S-P-Y-D-E-R, to sort of demonstrate this. If you're using something else, then that's perfectly fine. Just keep in mind that there might be some differences in the formatting and how the screen is laid out. But this over here is the editor window where I'm moving my cursor around. That's the editor window. That's where all the Python code goes. And when I go to run it, I'll usually get some sort of output, and that output comes out in the console, which is over on the right hand side of the screen here. And we'll see stuff pop up in that console as we go through it and as I demonstrate some little code snippets. But just to start things off, we'll take a look at some variables and some basic arithmetic in the course of this segment. So to start things off here, up here on line 1, you can see line numbers on the left hand side of the screen. Up on line 1, I have this funny little statement which is setting x equal to 3. So this equal sign right here doesn't really serve the same purpose or function as an equal sign from your regular math classes. In your regular math classes, if something is equal to something else, it means both sides of the equation are equal to the same thing. It doesn't quite work that way when you're working with a computer programming language. The way that the computer is going to interpret this is whatever's on the right-hand side of the equal sign, that's going to be evaluated and stored in whatever's on the left-hand side of the equal sign. So in the case of what's on line 1 here, what's on the right-hand side of the equal sign is just the number 3. That's really simple to evaluate. That's just 3. There's nothing else to it. So it's going to take that value of 3 and then store it on what's on the left-hand side, which is this variable x here. And the order here is important. So whatever's on the variable name must go on the left-hand side, and all of the math and everything must go on the right-hand side of the equal sign. There's no way that you can get around that. That's the way it has to be. Whatever's the math and everything that you want the computer to calculate must go on the right-hand side, and then the variable name itself goes on the left-hand side. And down here we have a second variable, which is given by this lowercase y, and we have that set equal to 10 here. So we have two variables, x which we set equal to 3 and y which we set equal to 10. So right now I have two variables that are just a single letter, but you can have variables that have multiple characters in them. In fact, that's usually something that you want to actually do, because a lot of times you want to give variables a name that is intuitive. It's a way that you can know right away what exactly that variable is holding on to, what value that variable is holding on to. So an example of that might be this variable, the sum, which is storing the sum of two numbers. So that way, if you're thinking about what's the sum of the two numbers that I have, then you see this variable name as, oh, it's just the sum. It's a nice and intuitive variable name for us. And what we have here on line 4 is some arithmetic going on the right-hand side of the equal sign. So we have x plus y. So the way the computer is going to interpret this is it's going to take the current value of x at this point in the program, which is 3. We can see what's up. We can tell that by what's at the top of the screen here, as well as the current value of y, which we can see is 10. Add those two numbers together, get a result, and then that result gets stored on the left-hand side of the equal sign. So it's going to evaluate this x plus y expression, get a result back, take that result, which in this case we expect to be 13 if the computer is doing math correctly. We expect that result to be 13, and that result will then get stored in our variable, the sum here, which is on the left-hand side of the equal sign. So that's what we expect. And here we have something called a print statement. A print statement allows us to get some sort of message or result from the computer, a result that we can actually see, because as it is right now, the computer is not actually going to print out the result of what's being run on lines 1, 2, and 4 here. This print statement tells the computer that we want some sort of output that we can actually see with our human eyes, and that output will actually go in the console here. So that's the whole idea behind this print statement. And anything that's in quotation marks here, the computer's literally going to print that out. And then anything that's not in quotation marks, it's actually going to look up the value of this variable, a variable given by what's not in the quotation marks, and then print out what the value of that variable is. And if you have a quoted statement and an unquoted statement or unquoted segment, you have to separate those two with a comma. So if you go from quoted, which means literally print this out, to unquoted, which means look at a variable called this and print out whatever it's holding on to, whenever you have two of those segments in the same print statement, you must include the comma here, whether it's quoted to unquoted or unquoted to quoted, you must have the comma there anytime there's that transition taking place between a quoted and unquoted segment, or vice versa, an unquoted segment and a quoted segment. So that's what this print statement does right here. It just literally prints out this text, the sum, and we tell it to print out whatever the value of the sum is. And there's a lot of other print statements in this program, but just to sort of get a bearing on what this actually looks like, you can see. So if we focus on, there's a lot of other print statements in here, but if we focus on the one we were just looking at on line 6, this is the result that it gave back to us. So you see it literally printed out the sum, also add an extra space here, and then it printed out whatever the value of the sum was, which we determined to be 13, and lo and behold, there is our 13 there. So let's look at addition. If we want to do, which uses the plus sign here, if we want to subtract two values or more, we could subtract more than two values if we wanted to, but if we want to subtract two values, then we just simply use the minus sign. And here I've got some different variable names here. So if I use, say, the sum is equal to x minus y, then whatever the old value of the sum was will be gone. If we use the same variable name, so if I had the sum is equal to x minus y, that means the old value of the sum is going to be thrown out and it's going to be replaced with something new. So this is one really important thing to keep in mind about variables is each individual piece of information that you want the computer to keep track of must have its own distinct variable name. Otherwise, it's not going to function the way that you want it to. So every unique piece of information that you want the computer to keep track of must get its own variable name. So in this case, I want the computer to keep track of the result of taking the value of x minus y and a separate variable so that I know the computer's keeping that a separate variable to restore the result of y minus x. And you can see when I ran the program here, I got the result of these two print statements, lines 12 and 13, to get one difference is -7, because 3 minus 10 is -7, and then another difference, which is just 7, because that's just 10 minus 3, which is +7. And again, that makes use of the little hyphen here. That's how the computer subtracts things. Multiplication gets a little bit more interesting. So in the case of multiplication, if you're multiplying two things together, whether that's two variables, two numbers, a number and a variable, or whatever it might be, this asterisk must be present. There's no getting around that. If that asterisk is not there, you're not going to get any sort of multiplication. It might be tempting to write this like you would any other algebraic expression where you just like the one variable next to the other, but the computer is not going to interpret that as multiplication, is instead going to interpret that as look for a variable called xy, take its result and put it in the product. Since this variable does not exist, you will get this lovely error message. Name xy is not defined. Anytime, underscore, italicize, bold, anytime you want to multiply any two things together, the asterisk must go between the two things in question. Otherwise, the computer is just going to flat out refuse to do anything that you want it to do. It's just going to give you some sort of error message, or it might just do something completely unpredictable. So just make sure that anytime you multiply two things together, you have this asterisk here. Otherwise, it's not going to work the way you want it to. But you can see here I have the product is equal to 30, which is in fact the result we expect from multiplying 3 by 10. Now, moving on to division. So division makes use of, there's actually three division-related operators that Python utilizes. One is the standard division, which is given by this single /, and that results is going in a variable called one quotient. We have one quotient equals y/x, so that means take y, which is 10. We haven't changed y at any point in our program. 10, divide that by x, which is 3, so that'll give us 10 divided by 3. And you can see the result of that in the console here. We get 3.333333333333, and then an infinite number of 3's after that. Now you might be looking at this console and wondering, what in the world is this 5 doing here? And the reason why that 5 or that last place, that last digit, it might seem a little off, that's just a consequence of how the computer holds on to what are referred to as floating point numbers. So whenever a computer is holding on to a floating point number, which is a fancy way of saying a number with decimals, the computer will have to make some sort of approximation or rounding for the very last digit. So you might see some errant values here, but usually that's nothing to worry about. So if you start seeing weird numbers at the end of these long decimals, it's usually not a cause for concern. It's just a consequence of how the computer holds on to, how the computer's memory manages numbers that contain decimal places. But that's just a look at some ordinary division. And then the second operator I have is given by two consecutive /s here. This will do regular division. So this will do a regular division of sorts, but you can see in the first case we had a bunch of 3s following the decimal point. This division operator will basically just say screw all the 3s that come after the decimal point. This basically does regular division, and then the end result is just made to be an integer. And this does not round down. It doesn't do any sort of rounding. It just takes anything that's after the decimal places and just chops it off. There's no decimals contained anywhere. It doesn't round up. It doesn't round down. It just loses anything that appears after a decimal point. So that's why this print statement on line 30 gives us this result. Gives us just a 3 without all the extra 3s that appear after the decimal point. And finally, the third division operator that Python can work with is given by this percent sign here, which is technically referred to as the modulus, where it does something division related. It actually does one number divided by the other, but the end result is not the quotient. The end result is actually the remainder term, if there is one. If there's no remainder term, the result's just 0. If there is a remainder term, then the result you get back from that is just the value of that remainder term. So 3 does not divide evenly into 10. And if you work that out using classic elementary division, you will get the result is 3 with a remainder of 1, and the modulus gives you that remainder term, which is just 1 in this case. 10 modulus 3 will actually give you a result of 1. Again, it's giving you that remainder term, and that's why the modulus here is equal to 1. And a couple other things that we want to explore. One is the exponent operator, which is given by the double asterisk, where here we have y double asterisk x. The computer is going to read that as the value of y raised to the power of x. And just to refresh your memory on what those two values are, y is 10, x is 3. So it's going to raise 10 to the power of 3. 10 to the power of 3 is 10 cubed, or 10 times 10 times 10, which is of course 1,000. You can see we have that result in the console here, and we get that result from running this print statement on line 52. Now, very common mistake that I see is using the caret symbol. Python, this actually does something sort of mathematical, but it's not going to be anything exponent related. In fact, you can see the result we get back from doing that is 9. If that confuses you, great. That means you will not use the caret symbol, this little symbol, to raise one thing to the power of something else in Python. When you're raising something to the power of something else in Python, you have to use the double asterisk here. There's no other way around it. You must use a double asterisk to raise one number to the power of another number. And one last thing that I want to point out that gets back to all the math that we've been discussing is that Python does in fact automatically follow order of operations. So whatever is in parentheses will be evaluated first, and then that result can be used to do some other math that might be involved. So here, since I have the set of parentheses here, I'm telling Python I want to add x to y first, which is going to be 3 plus 10, which is going to give me 13, and then take that, once we finally have that number, take that result and multiply it by the value of y. So this will give me 13 times 10, which is 130, and you can see we get that result from this print statement on line 61 here. So that's going to do it for the sort of introductory segment. Hopefully this was mostly review, but if not, then make sure that you thoroughly understand everything that's going on here, because the project is going to involve a fair amount of math. So I'd make sure that you understand how to use all these mathematical operators. So hopefully this all makes sense. That's going to do it for this first segment, and in the next segment we will discuss loops.